Good day, everybody. I would like to tell you about few things about algorithms and programs. First of all, about algorithms, folks. Algorithm is program made explicitly precise with graphical form. And I would like to give you a couple of samples. Algorithm is applicable for any device or any computer control mechanism. Consider that we have a robot that can walk from one end of the room to another end of the room. And this is our robot, and it can actually walk. But it will be controlled by computer. And this is place of starting, point A, and this is point B, the opposite wall, where robot must be stopped. What the purpose of walking through the entire room? Because every step of the robot is 1 foot, and I would like to measure the length of the room with the robot foot and describe it. I don't know what computer actually control this robot, but I know that my algorithm that I would like to represent to you will control the robot independently from any computer that applicable for robot controlling. So let me start. Folks, definitely algorithm will be start from the word start. And as I told you, that algorithm actually is a diagram. It's a graphical diagram. So when we measure something in foot, I would like to establish a counter which will be increased by a single step every time the robot made step. So counter, and counter will be n. N in the computer could be any memory cell. We have a freedom to distribute cells. And also we need number 1. So that will be 1 that data that will be increased the counter. Okay, so let's start. First, I would like to send 0 to the counter. This arrow actually, folks, meaning a record or sent or put. So now 0 will be sent to the memory cell which represent n. So if I say this memory cell in this case will be totally zeroed as soon as memory cell is multi-bit. In the computer it could be 32 or 64 bit. That is 4 or 8 byte. After we sent 0, I would like to command robot to make a step. And this is arrow connecting these actions. Make step. So robot made step, and then next command will be increase the counter, 1 plus n calculated value, and then I will send it back to n, which meaning we'll substitute all zeros with the result of this sum. So I don't know which one could be substitute, which value will substitute the value of n, but in the first run of this algorithm that will be n equal 1. Then the most interesting part of this algorithm. A robot cannot be crushed or destroy the wall. So I need to stop robot right in front of the wall. So I need to give command to optical system of this robot, and that will be conditional operation, folks. Conditional operation is operation that actually has a fork with logical yes and logical no. What the condition will be checked here? Is the wall here? Is the wall here, folks? When the robot came very close to the wall, the optical system of the robot will detect the wall in front of it. So the wall will be here. So if yes, we need to print N and then stop the robot. But folks, if the answer is no, then meaning robot is in the middle of the process, we need to go to next step making. Again, how this algorithm is working. Look at this. Start, then we prepare the counter and to accumulate the number of steps. Then we'll go make step. That our robot will make step. So we counting this step done in the counter. So in this case, counter will be equal 1. Then the question, is the wall here? Definitely no, because we made only one step. Then the arrow will go cyclically, make step again. And after that, the counter will be increased again. By what increment? Increment will be 1. So counter now will be 2. Is the wall here? No. Next step, counter is 3. Is the wall here? Counter is 4, and so on and so on. More cycles. Then when the robot will come to the wall, then we will stop the robot, print N, so we will know how many feet is the length of the room between two walls. So that is simple algorithm, folks. But this algorithm is not universal. I would like to give you a situation when the robot will go from point A, the wall, and it will go, and consider that this is wall of the house, and next wall will be never in front of the robot. So the robot could go and go and go. So in this case, let me show you the robot. The robot will go and go and go and will never end. So we need to know that a regular room, if robot inside of the room, the regular room cannot be more than 50 feet or 100 feet long. So the room that we experience, make this experiment, is about 100 feet long. So how algorithm will look in this case? We cannot force the robot to go and go and go indefinitely. We will lose him, and the battery juice will be ended. So what we need to do to create algorithm in this case? Let's go for start. We'll modify algorithm that we made. Start. Then what data we need? We need also 100 steps. Start, 0 send to the counter. Then I'll go a little bit more compact, make step. Then I will make 1 plus n send to n. Then I need to check, is the n equal 100? Because when at 100, I need to stop robot, because I will consider the robot is outside of the room and there is not possible to measure it. So is n equal 100? No. So I don't know where we are, inside of the room or outside of the building. So if no, I need to go to check. Another logical check, is the wall here? And if no, I will go to make step, no. But if yes, I need to print n, and then stop. But what happened? So that is yes. What happened if yes is here? Meaning the n is equal 100, and we actually exceeded the limitation of robot battery, and robot cannot walk anymore. So what we need to do? we need to print information that no outside wall, and then we'll go to stop. Now you can see a little bit more complicated algorithm where we have two conditional operations, two conditional modules, which actually can provide two check. One of them when we inside of the room and the limitation of the steps is not exceeded, so we can go cyclically, but every step done we need to check n is equal 100, meaning we are exceeded the number of steps or we will still inside. If we exceed it, yes, we put no outside wall and then stop. So this is how this algorithm works. Alright, now folks, I would like to show you how algorithm could be converted to program. Consider that we have algebraic calculation that we need to do. That could be anything like a mortgage, monthly payment, or percentage for loan or whatever. And I would like to input the formula, which is y as function is equal x squared plus 2b minus c divided by k, where x, b, c, and k are variables and y as a result of the formula. Definitely formula, that is b. Definitely formula, folks, in algebraic form cannot be calculated because computer dealing only with numbers that is not calculatable. So we need to input variables manually from the keyboard before we start calculations. But for inputting and for calculations we need to reserve cells for each variable. Consider that cells has numbers which named address, and these numbers as well as cell created to keep and hold binary code. So when I put the address like this, that will be 1000, and I'll put this bracket which means content. You can calculate 1000, that is 8 decimal, that is decimal value of this address, and I will dedicate this cell to x. So the variable x in my prognosis will be here. Then the next one, 1001, I will reserve for b. I need to have cell 1010 for the constant 2. Number 2 also must be in a cell because we need to make multiplication. Then next cell, randomly I will take one, let's say 1011. That cell will be reserved for C, okay? And one next cell, 1100, will be here for K. Definitely I need to put cell for Y. That will be 1101 if we consider all cells in sequence. So that will be cell for Y. Also, folks, we will force user to input value for each variable. So I need to have a reserved cell for the words, and that will be 1110, cell for the word type value, and that will be in apostrophe, meaning that is textual constant, textual value of the cell. And next one will be 1111, which is cell number 15. I will put here type value X, B, C, and K. Again, I put apostrophe here to indicate that this is textual information, and then when I display this, the user will see the word type value X square, B square, C square, C comma, and K. So that is X, B, C, and K value in sequence that user must type in a using keyboard. So now I would like to start this program. So definitely I will start this calculation, start, and the first will be the command display. Display, folks, the command which will be send a certain information in a textual form to the monitor, and that will be display two cells in sequence 1 1 1 0, and the next command display cell 1 1 1 1. Folks, that meaning in the monitor the user will see information type value X, B, C, and K. Then after user typed all these values, he put enter, and then program will go further. Then we need to put write value X to cell 1000, write value C to cell 1011. Next, X, write value B into cell 1001. So we put X, B, and C, and then write value K to the cell dedicated to K, 1100. So folks, this is input data. Next we will start calculation part. What we need to do, read X, read content of the cell 1000, meaning 1000, and then multiply. I will put multiplication symbol, multiply by itself, so multiply by the cell 1000. So in this case I'll put commentary here. We calculated X squared. Then we need to add 2b, but we cannot add 2b. We need to calculate it. So first of all, let me use additional cell, which will be working cell, that I will put some results which we need before. We will calculate, that will be 10000. Okay, write X squared to the cell 1000. That is the next cell. Then I need to calculate 2b. Multiply. Oh, that is a mistake. I don't need to multiply. I need to read cell 1010, which is 2, and then multiply by b. B is cell 1001. So here I calculated 2b. 2b must be added to X squared, but we use X squared here. So what we need to do, plus cell 1000, so 10000, cell 1000. Now in this case I have X squared plus 2b. What else we need to? We need to subtract C. Minus, what is C? C is 1011 minus 1011, which is cell for C. In this case we have commentary, which is X squared plus 2b minus C is in microprocessor. Then we need to divide by K, but K is in a cell 1100. So we calculated formula, but what we need to do, we need to put result in Y. Where's Y? Write what? 1101. So we'll put result of the formula in a cell 1101, which is the entire formula will be in a Y. Then we can go and display 1101, which is Y, and then stop. So folks, that is how calculation of the simple formula looks like inside of computer instructions that will be going through the microprocessor. Question, where they will be, these instructions? I consider that could be further in the further cells. Cell 1001, that will be first command, in a cell 10010, that will be my second command. So they will be enumerated and will be placed in memory further downstairs with all the data that been here. So thank you for watching this video, folks. Now you understand how computer program actually can calculate data, input data, and get result. So I would like to mark up this point, that is calculation part. which this one is input data. Oh, by the way, display is output. Thank you again.